Good morning, students. Our today's chapter is number systems and topic is how to represent an irrational number of the form root over x, where x is not a perfect square number and x is a rational number having terminating decimal expansion on the number line. In the previous class, I had taught how to represent an irrational number of the form root over n, where n is a natural number but not a perfect square number on the number line. We can use two different methods to represent an irrational number on the number line, and they are a spiral method. This method is used to represent an irrational number which is of the form root over n, where n is a natural number but not a perfect square number. And in last class I have taught how to represent root over 2, root over 3, root over 5, etc. on the number line by using a spiral method. Another method is semi-circle method. This method can be used to represent an irrational number which is of the form root over n, where n is a natural number and n is not a perfect square number. And this method can be used to represent an irrational number on the number line which is of the form root over x, where x is not a perfect square number and x is a rational number having terminating decimal expansion. Now I am going to take one example of an irrational number which is in the form root over x and x is not a perfect square number and x is a rational number having terminating decimal expansion. I am going to represent root over 9.3 on the number line, and I have taken this question from exercise 1.4, and the number of the question in the exercise is 4, and therefore I am writing here exercise 1.5 question number 4. Represent root over 9.3 on the number line. This is an irrational number. 9.3 is not a perfect square number, and 9.3 is a rational number having terminating decimal expansion. First of all, I am going to draw a line. This is a number line L. Let us now mark a point O on the number line which represents 0 on the number line. We have to represent root over 9.3 on the number line, and therefore I am going to take a point on the left side of O where the distance between O and the point is 9.3 units. Before I said take the point, I am going to draw a line segment whose length is 9.3 unit, and one more line segment whose length is 1 unit. This is 9.3 unit because we are going to represent root over 9.3 on the number line. This is 1 unit and this is the fixed unit. Not from the length point of view, length of 1 unit may be different, but we will take 1 unit only. Using compass, I am going to take a point on left side of the point O, which is equal to 9.3 units. A is a point on the line where OA equal to 9.3 units. This 9.3 is equal to this 9.3 if we are told to represent root over 4.5, then we will draw here 4.5 unit. If 7.8, then we will draw 7.8. 11.3, then we will draw 11.3. But this line segment which represent 1 unit is fixed for all questions. We will not change. And this is 1 unit. the length of one unit may be different, but whenever you take a point here, let the point be represent 1, and therefore the length of OB equal to 1 unit and the length of OA equal to 9.3 unit. This is fixed, 1 unit. 1 unit fixed, and you can take 1 unit as 1 centimeter, 2 centimeter or 1 inch as per your convenience. Similarly, here 9.3 units, we will use this length as 1 unit. Now, I am going to represent root number 9.3 on the number line by using semicircle method. By taking AB as diameter, we will draw a semicircle. And in order to draw a semicircle, we need center of the semicircle. And you already know the midpoint of the diameter of a circle or a semicircle is known as the center of the circle. That is semicircle. Here I am going to find out the midpoint of AB. In order to find the midpoint of AB, we will have to draw the perpendicular bisector of AB. And I am going to use compass to draw the perpendicular bisector. You already know how to draw the perpendicular bisector. You have already learnt it in the previous classes. This is a part of geometry. And sometimes we say the geometrical representation of root over 9.3 on the number line. This is also the same question what I am showing. Here, using compass with center A and radius more than half of AB. Obviously, this length is more than half of AB. I am going to draw two different arcs on either side of the line. Again, with center B and the equal radius, with an equal radius, I am going to draw two arcs which intersect the previous arcs at two different points. Using a scale, I am going to mark a point on AB. Let C be the point which represent the midpoint of AB. With using compass with center C and radius BC, that is AC. Whenever you draw, you will check on both sides whether these 2 points are equidistant from the center C or not. If they are equal, then you will draw a semicircle. Now, this is the semicircle with center C and diameter AB. I am draw perpendicular on the line with the point O. This is the point O which represents 0 here. This is perpendicular on the line L, that is AB. The perpendicular and semicircle intersect at a point, say D. The length of OD represents root over 9.3. This length represents root over 9.3. Now I am going to use compass. Once again, using compass with center O and radius OD, I draw an arc which intersects the line at a point, say P. The point P corresponds to the number 9.3 on the number line. Now I am going to justify our answer. Justification. In order to justify, we will join C and D. Clearly, triangle COD is a right angle triangle with angle COD equal to 90 degree and OD equal to root over 9.3. AB equal to AO plus OB, AO equal to 9.3, what we have taken from question, and OB equal to 1 unit, and 1 unit will be taken for any question which is in the form root over x. This is equal to 10.3. Now AC equal to BC equal to 1 by 2 AB equal to 10.3 by 2. Since CD equal to AC equal to BC equal to radius of semicircle, therefore we can write here CD equal to 10.3 by 2 units. Let us find the length of CO. CO plus OB equal to BC. Since CO plus OB equal to BC, this implies CO plus 1 equal to 10.3 by 2. This implies CO equal to 10.3 by 2 minus 1. This implies CO equal to 10.3 minus 2 by 2 equal to 8.3 by 2 units. Now, from right angle triangle COD, we have OD square plus OC square equal to CD square by Pythagoras theorem. OD square OC square, OC equal to, that is CO equal to 8.3 by 2 whole square, CD equal to 10.3 by 2, and therefore length whole square. Now OD square is equal to 10.3 by 2 whole square minus 8.3 by 2 whole square. This is in the form A square minus B square. And you already know A square minus B square equal to A plus B and into A minus B. Now I am going to use this identity, that is A square minus B square equal to A plus B into A minus B. This implies OD square equal to 10.3 by 2 plus 8.3 by 2 into 10.3 by 2 minus 8.3 by 2. This is equal to 18.6 by 2 into 2.0 by 2 equal to 9.3 into 1.0, which is equal to 9.3. Therefore, OD equal to root over 9.3. Justify. And hence we can write, that is, thus the point P represents root over 9.3 on the number line. Today only this much. See you in the next class for the rest. Thank you.